Hello everyone, my name is Atul Yadav. I am going to present a seminar presentation on the topic of Stad Ship Tunnel. In the next slide, we have the table of contents. So the first one is introduction, then need for Stad Ship Tunnel, planning of Stad Ship Tunnel, construction process, technical specification, technologies used, case study, benefits and future plan. So moving to the first slide, we have the introduction part. So basically, Stad Ship Tunnel is world's first underground planned canal tunnel for ships. Stad Ship Tunnel connects western Norway by passing the Stad Peninsula in Vestland County, Norway. It aims to enhance the maritime safety and efficiency of vessels through Stad Sea by avoiding dangerous stress of Norwegian coast. The total estimated cost of the project is around $318 million. In the next slide, we have to discuss why we need the Stad Ship Tunnel. So the Stad is the ocean surrounding the Stad Peninsula and the part of the Norwegian coast. This sea is considered as the most weather exposed and dangerous sea of Norwegian coast because it is a meeting point of the North Sea and Norwegian Sea. Due to this, unpredictable high waves up to 30 meters are generated, as well as combination of wind and ocean current makes it stormy for 100 days in a year. The combination of subsea topography and ocean currents which makes critical sailing situation for vessels. So the movement of ship through this sea is not safe, and ships have to wait few days for the clearance to approach to the closest harbor. So this land surface is called as Stad, and the water surrounding the Stad is called as Stad Sea. So a tunnel is proposed at the narrowest part of Stad, and this is the location of the tunnel. This tunnel is proposed to set up and bypass to avoid the Stad Sea, and the length of the tunnel is 1.7 km. So the tunnel was proposed to provide safe and alternative route for ships to give them a bypass of Stad Sea and interconnects western Norway. This tunnel also reduces the waiting time and sailing time between Norwegian cities. The tunnel was proposed in 1874 by Norwegian Coastal Administration. Extensive research testing was done long before approval was given in Trondheim. After decades of planning, the project was first proposed in 2017 and included in National Transport Plan in 2018 to 2029 and approved in March 21. In this slide, we will see the construction processes involving during the construction of tunnel. Construction work starts from excavation of material from each ends of the Stad, creating two tunnels that joins in the middle. The roof of tunnel is reinforced with shotcrete immediately after excavation. Then the service routes are added to remove the excavated material. This works will performed in layer by layer from top to bottom, in which tunneling of one layer is completed, then another layer is to be digged out. To excavate the tunnel floor below the sea, coffer dams are constructed at the ends of the Stad, which will protect water not to enter in the tunnel. These copper dams are designed by a architectural firm Snøhetta. Then these copper dams are removed and allowed it to pass a canal through a tunnel at a depth of 12 meters. In total, 8 million tons of rocks are removed from excavation. From that, some portion is used for future projects and other material is used to be transported from the sites. Transportation of excavated material away from the site is challenging due to the lack of decent road in the Stad because Stad Peninsula is an hilly region. So remaining excavated material is carried away by the barges, which is also known as ships. About 4 million tons of rocks, which is excavated from the tunnel, is also used for the constructing and commercial area near the tunnel. In this slide, we will discuss the technical specification of the tunnel. The tunnel is 1.7 km long, 36 meter wide and 49 meter in height with a water depth of 12 meter. The tunnel is capable of handling ships weighing up to 16,000 tons of weight. The tunnel is designed for one-way traffic movement and can accommodate the passage of 120 ships per day. The design speed of a tunnel is restricted to 8 knots. In this slide, we will discuss the various technology that are used in the construction of Stad Ship Tunnel. First one is bench blasting. It is a mining technique that involves removing thick ore zones by blasting a series of horizontal layers called benches. Second one is slope terrace, a technique used to blend tunnel entrances into natural landscape to avoid the erosion of stones at entrance. Third one is shotcrete. It is a construction technique used to reinforce the temporary and permanent excavation in underground construction projects. Shotcrete consists a dry mix of aggregate conveyed through compressed air and water is added at a nozzle. And the fourth one is the cofferdams. It is a temporary structure which creates dry work environment by keeping water and soil out of the excavation. So moving to the next slide, we have case study of Recuval Towing Tunnel. It is 5.67 km long tunnel was built between 18,001 to 18,010 by Napoleon in Saint-Quentin Canal in France. This tunnel connects Bellicourt with Bonny. The purpose of tunnel to allow the boats to travel from Somme Basin to Escaut Basin. Chain towing technique is used in sailing the boats through the tunnel, in which an electric boat was used to tow barges through the tunnel of an average speed of 2.5 km per hour in the tunnel. On the next slide, we are discussing the benefits of the Stad Ship Tunnel. Stad Ship Tunnel achieves the political goal of moving transport from road to sea and facilitate safe and environmentally friendly sea transport in the coastal region. Due to this tunnel, a bypass has been set up in western Norway, connecting the harbors of all major cities in the region. And it provides the fast boat passenger route from Bergen to Elsund of distance 310 kilometers. The fuel consumption of the ship is reduced by 30 to 60% by using this route. Due to this lower fuel consumption, there is reduced CO2 emission resulting in a positive impact on the environment. It also boosts the housing and labor market in the western Norway. In the next slide, we are discussing the future progress in the project. So in 2023, a new cost and uncertainty analysis indicates tunnel is more expensive than planned. So the Norwegian Parliament will consider a new and increased cost framework in budget for 2024. The contract signing is scheduled for the spring of 2024 to secure a contractor with construction slated to commence in early 2025. The tunnel project is anticipated to take 4 to 6 years to reach completion. So the Stad Ship Tunnel is expected to be finished by 2030 and subsequently open to traffic. At last, I would say thank you.